and welcome. There are 4 variables in the blackboard. A nav mesh agent variable. A health variable. A damage variable. A particle system variable. There are 3 variables in the graph blackboard. The targets and site variable, which stores all objects in the agent's field of view. The target variable, which stores the selected target from the targets and site variable. The target behavior tree variable, which stores the selected target's behavior tree owner. Nodes in the behavior tree. The AI sensor node, which stores information about objects that enter the agent's field of view. Obstructions are also respected by the sensor to prevent the AI from seeing through walls. Layers specify which objects get added to the targets and site list. Occlusion layer specifies which objects occlude others. The interrupt selector node, which aborts the move to random position node if the higher priority node changes status. The filter targets node, which picks the first game object with the specified layer and tag, then stores it in the target variable. It needs a reference to the AI sensor node. The way we do that is by right-clicking on the node we want to reference. Then select Copy and press the Paste button on the left of the field. You can add the Get Node Reference attribute passing the type of node you want to reference. The Get Target Info node, which is an empty action node that has the Get Component task. The Get Component task gets a component from a game object and stores it in the result variable. The Move Towards node, which moves to the selected target. Max time specifies how often the setDestination method is called on the agent. Attack Delay node, which waits for 0.1 seconds. This means the agent can attack 10 times a second. The Attack node has a Look at task, which looks at the target transform. This node sends an event to the target behavior tree with the damage variable. There is also an option to use self-behavior tree. Trigger Effect node, which is a reflected invoke node that invokes the emit method on the particle system. The Take Damage node, which has a health field that you can assign any integer or float variable. The Parallel node's action on failure, which is set to abort if it was set to none. The Destroy Object node would execute the first time the agent took damage. The Compare node, which checks if the health is less than 1. If the health is less than 1, the Destroy Object node will execute. The value type has to match the value we are comparing. In the Take Damage script, here we can see the health property. We use the Get Variable attribute to get the search window that displays all available variables. We get the health variable as an integer variable if null. Then we get it as a float variable, but if null we bail out. If the value is a float variable, we subtract the value from the health. Back to the graph. The Interrupt Selector node, which works with priority. A higher priority branch can abort a lower priority branch. The Search for Health branch has the highest priority. For example, if the agent is fighting another agent and his health gets too low, there is no point in continuing to fight. So he goes to look for health. We have a Compare node, which checks if the health is below 50. The Filter Targets node, which searches for a health pickup. If there is none in sight, the agent will walk to a random position. In the Health Pickup script, the Health Pickup script derives from the Pickup class. We get a Blackboard component if null we bail out. We get the health variable if null we bail out too. We cast the health variable to an integer. If the variable is not an integer variable, it returns the max value of the type you cast to. Head back to Unity and push play. Thank you for watching.
Alright, I live in my day. Rome wasn't built